Hello and welcome to today's class. For today's class, we're looking at a very important concept in complex numbers known as De-Moivre's theorem. Now, I know most persons pronounce this as De-Moivre's theorem, but you know that the name here, Moivre, is actually coming from a French mathematician. Just like Argan was a French mathematician, so was this man. Um, so in French, you know, the word moi in French is pronounced as not moi, but moi. All right, that's my. Right, this word here is pronounced moi in French and not moi as per English. So this becomes moi, and this one is vrai. All right, so this is actually De-Moivre's theorem, not just Moivre's theorem as they call it. All right, that's De-Moivre's theorem. That's your correct pronunciation. But that's by the way. I think it's quite stressful to pronounce that, isn't it? De-Moivre's theorem. De-Moivre's theorem. But calling it in the English form as De-Moivre's theorem is quite relaxing and much more easier. But that's by the way. Let's get this done, please. What's the concept about De-Moivre's theorem? All right. So what does De-Moivre's theorem say? For De-Moivre's theorem, it helps us to get the idea of De-Moivre's theorem is that it helps us to get the nth power of a complex number easily and faster too. How do we mean? Remember that in our previous class we talked about the multiplication of complex numbers in polar form. What we say, if you have a complex number z1, and we say z1 is equal to r1 into, let's say, cos theta 1 plus I sine theta 1, and we have z2 as being equal to r2 into cos theta 2 plus I sine theta 2. We said if you have this, then their product z1 z2, their product z1 z2 is equal to r1 r2 into cos of theta 1 plus theta 2 plus I sine theta 1 plus theta 2, and you have this. So we talked about this in our previous class when we did multiplication of complex numbers in polar form. If you missed the class on this, I'll leave a link to this class in the description of this video. So simply check the description of this video and you would see a link to this class. Now, but that's by the way. Let's proceed with this. What if in this case z1 was equal to z2? What if z1 and z2 were the same thing? So let's say z1 was equal to z2, and that's equal to r, no longer r1 or r2, just r into cos theta 1, or let's just call this theta, no longer 1 and 2, just theta, plus I, no longer sine theta 1 and 2, but just sine theta. So I have this. So if z1 is equal to z2, and that's equal to this one here, no longer 1 and 2, if I multiply them, I'll have z1 dot z2. Since they are the same thing, we can call them just one thing. Perhaps we can call them, let's just call them z, right? So z squared, for instance, because z1 and z2 are the same thing. So if it's z1 times z2, whichever way, let's just call it z. All right. If it's being squared, this will be equal to, now you have r1 times r2, but we said r1 and r2 are the same thing. So it becomes r times r, which is r squared, into, now this will become cos. Let me use square brackets here. This will become cos. Now I'll be having theta 1 plus theta 2. But theta 1 and theta 2 are the same thing. So it will be what there? Theta plus theta, that's 2 theta plus I sine. Same thing here. We are saying that theta and theta are the same thing. No longer T1, no longer theta 1 and theta 2. So I'll be having theta plus theta. That will give you 2 theta. So I'll have this one here. So please, we're saying that z1 and z2 are the same thing. So z1 times z2 is a number multiplying itself. We want to call it as z all squared. So I have this. So that will give me this one here. So it'll be r1, r2. That's r times r. That's r squared into this one here. If you want, you can still do the long multiplication. But I'm trying to save time here. Let's use z cube. What will z cube be? Z cube will be equal to, of course, that will be r times r times r. That's r to the power 3 into, this will now be cos. If it's cube, that means I'm having, in one side I'll have 2 theta, that's 2 theta in one side, plus in the other side I'll have another theta. Alright, that will give you 3 of theta. Same thing here, in one side I'll have 2 theta, so you can see here, 2 theta is from this, and then another theta, that's the third one, which I'm multiplying. So I'll be having this. So this will now give me something like 2 theta plus theta gives you 3 theta plus I into sine 2 theta plus theta gives you 3 theta. So if you look at this progression, perhaps you can guess the value of z to the power 4. Z to the power 4 will be equal to r to the power 4 into cos 4 theta plus I sine 4 theta. So this is like the correlation of how this will work in this case. So if this is true, that means if the part there is n, I'll have that z to the power n is equal to r. So when this was 2, I had 2, 3, 3, 4, 4. So when this is n, becomes r to the power n into cos, so cosine of no longer 4 times theta, but we said this should be n, so it becomes n theta plus I sine n theta. I would have this. So this is what is known as De-Moivre's theorem. De-Moivre's theorem helps us to do large expansion for complex numbers. All right. So this is De-Moivre's theorem. This is the expression. In words, De-Moivre's theorem says to take the nth power of a complex number, the nth power of a complex number. To take the nth power of a complex number, simply raise the modulus to power n and multiply the argument by n. That's all. So that's what the De-Moivre's theorem states. It states that to raise or to find the nth power of a complex number, simply raise the modulus to n and of course multiply the argument or the amplitude by n. That's the statement of the De-Moivre's theorem. Alright, so having said that, what does this help us to do? Now we'll take an instance. Let's say z is equal to 2 plus I to the power 2. This will be easy to solve because I simply multiply this as 2 plus I multiplying 2 plus I. That's easy to do. But what if I change this to 35, for instance? So z is equal to 2 plus I to the power 35. Now, this would be multiplying 2 plus I, multiplied by 2 plus I, multiplied by 2 plus 5, up to 35 places. And that's way too long and tasky to do. So in this case, now employ De-Moivre's theorem. And that's why De-Moivre's theorem is very, very important. It helps us to do, or it helps to take the nth power of a complex number in an easy way. So this is why De-Moivre's theorem is very, very important. All right, so having said this, let's see how we can take the, let's see how De-Moivre's theorem can actually help us in doing some calculations. So we'll take some examples and work with De-Moivre's theorem. All right, so let's look at an example on De-Moivre's theorem and how it helps us to solve problems pertaining to the nth power of a complex number. So let's say we're given 1 plus 2, that's half plus half I. We're asked to find the 10th power of this. Of course, having to expand this 10 times can be very cumbersome, so we'd have to use De-Moivre's theorem. From De-Moivre's theorem, we said z to the power n, a particular complex number to the power n is equal to r to the power n into cosine of n theta plus I sine n theta. We said this. All right, so if this is true, let's get n. Of course, from here, n is equal to the power. That's 10. Let's get r. R will be equal to the modulus square root of this. So square root of 1 over 2 all squared plus 1 over 2 all squared. So this squared plus this squared. So that will be equal to square root of 1 over 2 squared is 1 over 4 plus 1 over 2 squared all squared is 1 over 4. That means r is equal to square root of same denominator, so 4. I'll simply add up the powers. That's 2. So 1 plus 1 gives me 2. So if you do 1 over 4 plus 1 over 4, you have 2 over 4. And that's equal to, in short form, this is root 2 all over, this is root 4. And that's equal to root 2 all over, root 4 is 2. So r is equal to root 2 over 2. Next up, let's find the angle. Theta is equal to the tan inverse. So tan inverse of b over a. Tan inverse of b is 1 over 2. That's this. All over a, also 1 over 2. 1 all over 2. I have this. Tan inverse of b over a. And that's equal to, of course, this can cancel this. That's mathematically correct. So I have 1 over 1. So that means theta is equal to tan inverse of 1 over 1 gives you 1. Tan inverse of 1 is equal to 45 degrees. So we have this one here. We've worked so much with degrees. How about we work with radians? That's pi. All right, so let's just work with pi for this. We'll still work with degrees much more later, but we've worked so much with degrees for this. So let's try pi. Theta will be equal to, convert this to pi. What will it be? We said the value, the angle will be equal to 45 times pi all over 180. To convert from degrees to pi's, simply multiply the value by pi over 180. So that's equal to 45 here. So this is equal to, before this, 45 times pi is 45 pi all over 180. So that means the theta in this angle, the angle here, theta is equal to 45 here, 1, 45 here. That should give you about 4 times of it. So that should be equal to pi over 4. So theta is equal to pi all over 4. So that's my theta, the angle. So hence, using De-Moivre's theorem, what do we have? All right, we'd have that 1 over 2 plus 1 over 2i to power 10 will be equal to r. What's r again? This. So root 2, that'll give you root 2 all over 2. That's r to power 10. Okay. Next up, I said into cos. So into cosine of n. N is 10 there. So 10 times theta. We're using the radians form. That's pi over 4 plus I sine n. N there is 10. So 10 times theta, which we got here as pi over 4. So I have this. All right, so this is equal to, let's see if we can simplify this using a calculator. Okay. All right, so simplifying this using a calculator. So I'm getting all of this at once. Let me see if I can get this. Root 2 all over 2 all to power 10. So if you punch this with the calculator, this would give you 1 all over 32. So you can go ahead and simplify this. Next up, this now gives you into, I have cos 10 pi over 4 plus I sine 10 times pi, 10 pi over 4. So I have this one here. All right, so simplify this. What do we have? This is equal to 1 over 32 into cos 4, 2 here, 2 here, 5. That's 5 pi over 2, 5 pi over 2. That's in lowest term, plus I sine, same thing here, 5 pi all over 2 to the lowest term, or to the basic form. I have this. So this becomes the answer. This one here is the value of this. This one is in radians. Let's get this in degrees. To get this in degrees is very simple. Simply put theta, or simply put pi as 180. So pi will be equal to 180 degrees to get this value. So what does that mean? It means that in terms of degrees, this one would be equal to 1 over 32 into cos 5 times 180, pi is 180 degrees, all over 2 plus I sine 5 times 180, so 5 times 180 all over 2, and I have this. Okay, so what do you have here? So this will be equal to 1 over 32 into cos. So let's get 5 times 180. That's 900 over 2. That's 450. That's cos 450. Now in degrees, plus I sine 450 in degrees. So I have this. That will be equal to, you can choose to convert this, or let me go straight, cos 450. All right, so cos 450 here, if you punch this in the calculator in degrees, this gives you 0. All right, sine 450 gives 1. So this one gives you 1. So in essence, this is equal to 1 over 32. This one gives 0. So it's off, plus, I'm having, sorry, multiplied by, so this is 0 plus 32 into 0 is off, plus I times 1, that's I. So this one gives you I. You can punch this, sine 450, you have I. That's I. So if I multiply this, this is equal to 1 over 32 I. So you have this answer. All right. So I've gotten this value. All right. So this is how we can use De-Moivre's theorem to simplify getting the nth power of a complex number. All right. So this is how it's done. All right. So this is how we work on De-Moivre's theorem. All right. So let's take another example on De-Moivre's theorem. So this question says express 1 plus I to the power 20 in the form a plus ib. Now, in this case here, we have to use De-Moivre's theorem because the power here is quite large, and we can't start expanding this or by multiplying itself one by one. That will waste time. Let's use De-Moivre's theorem straight up. So that will mean, let's get R first. From here, of course, if I have 1 plus I to the power 20, it means that n is equal to the power, that's 20. R is equal to the square root of d squared, 1 squared, plus, I'm having I, coefficient here is 1, so 1 squared. So that's equal to the square root of 1 squared is 1 plus 1 squared is 1. That's equal to root 2. So let's get theta. Theta is equal to tan inverse of b, that's 1, all over a, that's 1, and that's equal to tan inverse of 1 over 1 is 1. So it becomes tan inverse of 1, which we got previously as 45 degrees. So that's tan inverse of 1 as 45 degrees. All right, so if this is true, let's now do the idea of De-Moivre's theorem. So from De-Moivre's theorem, so from De-Moivre's theorem, what do we have? We have that z to power n is equal to r to power n into cos of n theta plus I sine n theta. So I have this one here. All right. So in our first example, we said let's use theta, let's convert theta to pi and work with radians. But in this case, if I work with pi or radians, I won't get my answer in this form. So to get my answer in this form, I have to work with degrees. That's the idea, work with degrees. So that means 1 plus I to power n, that's 10, will be equal to r. R here is 2, or root 2, that's root 2 to power 10 into cos. So cos n that's 10 times theta is 45. So 45 degrees plus I sine n is 10 times theta, that's 45 degrees. So I have this one here. All right, so this is equal to root 2 to the power 10. Let's see your answer. Root 2 to power 10. The answer here is 32. So it becomes 32 into here. I have this as cos, that's cosine of 10 times 45 is 450 plus I sine 10 times 45 is 450. So I have this. Alright, so just punch this directly and see your answer. This is equal to 32 cos 450. I think we got that as 0. Yep. So this one here is 0. Sine 450 gives you 1. So that is equal to 32 into 0 plus I times 1. So I'm having this. So that is equal to, of course, this one is off. So 32 times 1 times I gives you 32I. So that's how we solve this question. We'll take a final example on De-Moivre's theorem, and then we'll look at something else. All right, so let's get our final example on De-Moivre's theorem. So this question says evaluate 1 minus root 3i to power 5 in the form a plus ib. All right, so how do we get this done? Very easy. For this one, we'll have to use De-Moivre's theorem. If you have the time, you could choose to expand this 5 times and see if we'll have the same answer. But then, I'm using De-Moivre's theorem. So 1 minus 3 root 3i, okay, to power 5. Let's get this done. So for this case here, n is equal to the power, which is 5. Let's get r. So r will be equal to the square root of this one here, 1 squared plus this one here minus root 3 all squared. So r will be equal to the square root of 1 squared is 1 plus, let's get this one done. This is minus root 3 multiplying minus root 3. Minus minus is plus. Root 3 times root 3 is 3. So my answer is plus 3. Okay, work on this. That's equal to the square root of 1 plus 3 is 4. And that's equal to the square root of 4 is 2. So I have this as 2. Next task, find the angle. So theta is equal to, before you watch this, please make sure you've checked our previous video on how I explained how to get theta and theta reference. So for this one here, you should know the quadrant, positive x, negative I. That should be quadrant 4. And you know how we get the reference. I'll leave a link to that video in the description of this video. So just check the description, you see a link to the explanation of how we get the correct angle. But let's proceed with this. So that's equal to, so theta is equal to tan inverse. So tan inverse of, we said you could forgo the negative sign. I'll just take root 3 all over 1. Okay, so b over a. So theta is equal to, okay, let me write the answer here. This will give you root 3. So tan inverse of root 3, my answer here is 60 degrees. 60 degrees here is my reference angle, which I explained in our previous class. So let's get the real value of theta. What will it be? Let's see this. To explain this in our previous class, we said you have this from the Adams diagram, you have this, and you have this. So I'm having this one here, 1 minus root 3i will be equal to 1 and minus root 3 here. So that's positive x, negative I. So positive x, that's here. Negative I, that's here. So hence, something of this nature, that's minus root 3. That's about 1 point something, minus 1 point something, because root 3 is 1 point something. So somewhere here, minus root 3, then somewhere here, 1 for x. So this one comes down, this one goes this way, and it will go like this. The theta you have is this one here, 60 degrees. Okay, this is my reference theta. So this is not just theta, but theta reference. We explained this before now. Okay, so my real value of theta will be from here to this point here, so this is theta reference at 60 degrees. My real value of theta will be what there? Theta here. So we know that for us to get theta here, we said this theta will be equal to 360 degrees minus theta reference. And that's equal to 360 degrees minus this value is 60 degrees. So my answer is equal to 300 degrees. This is the real value of the complex number. That theta is equal to 300 degrees. All right, so this is true. We can now use De-Moivre's theorem. So using De-Moivre's theorem, we'll have that 1 minus root 3i to power 5 is equal to r to power n. R here is 2. So 2 to power n is 5 into cos. So cos n times theta, n is 5. So 5 times theta is 300. So 300 plus I sine n, 5 times theta, 300. So we have this. Please, I'm saying again, this whole concept here, we've done this in our previous class. So to access this video, simply check the description of this video. Right? So if you check the description of this video, you see a link that explains what we just did here. All right, so I have this one here. Let's simplify this. So this is equal to 2 to the power 5. That's 32. 2 times 2, 4 times 2, 8 times 2, that's 32. So 32 into cos. This gives you 1,500 plus I sine 1,500. So I have this. So we can go ahead and punch cos 1,500. Okay, so we have an answer here. So this is equal to 32. If I punch cos 1,500, this is in degrees. This is in degrees. Okay, degrees this way. All right. Cos 1,500 is equal to minus root 3 all over 2 plus, there should be this one here. That's equal to 32 into, I'm having this cos 1,500 is equal to 1 over 2 plus I sine 1500 is equal to root 3 over 2. So I have this. What I say simplifying, this is equal to this times this, 32 times 1 over 2 plus I into this times this, 32 times root 3 over 2. This is equal to 16. So I'm having this as equal to 16. 32 times 1 over 2 is 16 plus I into this here 1, this here 16. 16 times root 3 is 16 root 3. So this is the answer here. We have to express in the form a plus ib. So it becomes 16 plus this one here. Work on this further. This is equal to 16 plus 16 root 3i. Alright, so this becomes our final answer. If you want to factorize this, you're free to factorize, but that's our final answer after solving this question. That's how we solve this. Just to check this, let's see 5 times 60, 300. Okay, 300 cost 300. Okay, so just to check this up, please. If you still use 60 here, our initial angle was 60 degrees. That was this one here. So if you still choose to use 60, becomes 5 times 60. That's about 300. So cos 300 will still give you the same value as this sine 300. Okay, sine 300 gives you a negative. Sine 1500. Okay, sine 1500 gives you positive of this. If I use sine 300, it gives you a negative of this. So that's why this is very important you get this concept. So if I use sine 1500, I'll have a positive of this, while sine 300 gives me negative of this. So that's why it's important you have this concept. All right, so this is how we solve this question. We'll leave up 2 questions for you. So you try these 2 questions. All right, so this is what we get. So observe that if I'd used theta as 60 degrees here, then this would have been correct. I would have had 1 over 2, which is correct. But if I'd used theta as 60 here, this would have been 5 times 60, which would give me sine 300, and then this would now be negative of this. So I'll be having 16 minus 16 root 3, which is incorrect. The answer is actually the plus and not the negative. So that's why Gann diagram is very important in our solution. So if you're done with this, please, these 2 examples, solve this and express both of them in the form a plus ib. Please, when you're done, leave your answer in the comment section. All right then, see you in the next class.